Welcome to aminacademy.com. In engineering thermodynamics, let us discuss about energy, work and heat. Energy is a general terms of embracing energy in transition and stored energy. The stored energy of a substance may be in the form of mechanical energy and internal energy. Other forms of stored energy may be chemical energy and electrical energy, potential energy like. Part of the stored energy may take the form of either potential energy, which is the gravitational energy due to height above a chosen datum line, or kinetic energy due to velocity. The, the balanced part of the energy is known as internal energy. In a non-flow process, usually there is no change of potential or kinetic energy, and hence change of mechanical energy will not enter the calculation. In a flow process, however, there may be changes in both potential and kinetic energy, and these must be taken into account while considering the change of stored energy. The heat and work are the forms of energy in transition. That means vice versa is converted. There are there are only forms in which energy can cross the boundaries of a system. Neither heat nor work can exist as stored energy. Heat is the energy associated with the random motion of a particles, while work is the energy of a ordered motion in one direction. Therefore, heat is low quality energy and work is high quality energy. And this supports the entropy statement of the second law. Delta equal to W plus Q here. Energy, change in energy is change in work plus change in internal energy. Heat, Q equal to heat energy and W equal to work here, total energy. Now we will discuss about heat versus work. Heat and work are two different ways of transferring energy from one system to another. The distinction between heat and work is important in the field of thermodynamics. Heat is the transfer of thermal energy between the systems, while work is the transfer of mechanical energy between two systems. The distinction between the microscopic motion, that is heat, and macroscopic motion, work, is crucial to how the thermodynamic process works. Heat can be transformed into work and vice versa. See the mechanical equivalent of heat, but they are not the same thing. The first law of thermodynamics states that heat and work both contribute to the total internal energy of a system. But the second law of thermodynamics tells limits the amount of heat and that can be turned into work. Some efficiency is there. Main differences. We will discuss about difference between heat and work. The second law allows work to be transferred fully into heat, but forbids heat to be totally converted into work. If heat could be transferred fully into work, it would violate the laws of entropy. The maximum amount of work one can attain from the heat is given by the Carnot efficiency, that is 100% efficiency, but it is theoretical, it's not practically possible. Heat is the energy associated with the random motion of the particles, while work is the energy of ordered motion in one direction. Therefore, heat is a low quality energy and work is the high quality energy, and thus support the entropy system of the second law. Heat and work each have their own distinct properties and they differ in how they affect the system. These are some listed: work and heat. Interaction, work is mechanical, here heat is thermal. Requires force and displacement, that is for work there must be force and displacement, and here for heat temperature difference we need. For process, macroscopic push and pulls is a work. Microscopic collision of molecules is a heat. If W is greater than 0, that is positive work, when a gas is compressed, energy is transferred into system. While Q equal to greater than 0, then we can say when the environment is at a higher temperature than the system, energy is transferred into system. For negative values, work is less than 0, that is negative work. When a gas expands, energy is transferred out of system. Q is less than 0 for heat, that when the system is at a higher temperature than the environment, energy is transferred out of system. For equilibrium, the system is in mechanical equilibrium when there is no net force or torque on it. Or a system is in the thermal equilibrium when it is at the same temperature as the environment. Now we'll discuss about reversible work. Reversible work means that the entire system, including the surrounding system, can be returned to the starting state. Irreversible work means that can only bring the piston back to the starting state if we change the surrounding system. True reversible work only occurs theoretically. Here it is irreversible, it's a reversible process. Now, what is specific volume? Specific volume is defined as the number of cubic meters occupied by the 1 kilogram of matter. That is, cubic meter occupied by 1 kilometer of matter is called specific volume. It is of a material's volume to its mass. That is, it is a ratio of material volumes to mass, which is the reciprocal of the density. Volume, specific volume is volume per mass, density is mass per volume. The standard unit for specific volume is cubic meter per kilogram or milliliter per gram or cubic feet per lb, pounds, like different units are there. So far we discussed about work and heat, energy, work and heat, and relation between them. We have done. Please subscribe our YouTube channel.